Well, Priya will be the one that's going to read the question, and I will be the one who's going to answer this question. So, Priya, you may proceed. Well, okay, excuse me, please. Like, the topic of this question is electrostatics.
Here we have two identical insulators, sphere X and Y, suspended by the thread from a ceiling, are held at a small distance apart as shown in the diagram below. Sphere X carries the charge of positive X times 10 minus 2
To the power.
That's
to the power minus 18.
to the exponent minus 18. 4 times 10 to the power minus 18 is coulombs. Yes.
While sphere Y has an excess of 30 electrons.
Yes. We are given the number of electrons. Thank you.
So the question is going to be calculate the magnitude of the charge of sphere Y.
Well, the formula of that question is N is equal to Q over QE. Well,
So there we are finding. How to calculate what? Sorry, rephrase the question again.
Calculate the magnitude of the charge of sphere Y.
So when you are given the number of electrons, again,
yes,
you want the charge.
yes.
So hence you substituted there as 30, which is the number. Now about a Q again.
Yes.
So is everyone okay with the procedure?
Yes.
Yes. So continue.
That will be 30 is equal to Q over -1, 6 times 10 to the power -19. Well, the answer will be Q is equal to -4, 8 times 10 to the power -18 coulombs.
So between now that you calculated the charges again, LG 4, no, that is negative again. Negative 4,8. So which one has the greater charge between sphere X and Y? X ke 4, Y ke minus 4,8.
Well, that will be
KF in and lay the greater charge. A and lay is it has more electrons. So what happened at sphere X? Do we have electrons or electrons were removed? It's positive again.
Yes.
So when they are brought into contact, electrons will move from where to where? X a positive, the electron retreat. Y a negative, in an excess electrons. So when they are brought into contact by the touch and separate, the electron will move from X to Y or from Y to X. Y to X. Because L is positive, so it will gain electrons. Yes, that is fine. So Y negative, or necessarily
Yes.
Good question. Okay. The second question, 10.2.
So it says the sphere are now released and they move towards each other. The question is, give a reason why sphere X and Y move towards each other.
Okay.
Well, the answer will be unlike, or you will be, or you either going to say that opposite charges attract.
Opposite charges attract. Positive will attract a negative charge. Positive charge attracts a negative charge. Or you can simply say that opposite charges or unlike charges are attracting one another. Yes, it's correct.
The spheres are
And you maybe the land clinic is a marking. I think we should put the marks there as well. Can we? The first one was 3 marks, I think.
Yes.
It is.
One formula, one substitution, one answer. The second one, how many?
2 marks.
Okay, yes. For saying they are opposite and for saying they attract, it's 2 marks. It's fine. The third one, I can see the total charge in an isolated system. The total charge is N. And grammatically, it cannot be possible. The total charge is N.
Isolated.
So I'm saying in N again. Sorry.
The total charge.
Shaba,
Give this N. The total system. The total charge is an isolated.
Like listen to the statement. How does listen to yourself when you are reading? How to state the principle of conservation of.
Oh, the total charge is in.
No.
Is the total charge in an isolated
Hey, carry. It can't, even if by quantity is, so it's a mistake. So it must be in. I get a more memorandum by quantity casino. Ka is. So it's a mistake. But replace it as a. So that you must know the principle. And as long as you know the word conservation, you must say isolated system remains constant. That's it. In that thing in an isolated system remains constant. The principle of conservation of energy. The total energy in an isolated system remains constant. Principle of conservation of charge. The total charge in an isolated system remains constant. That thing in an isolated system remains constant. So, the conservation, it's I think about 4 or 5 this year. So this was the first one. Yeah. Conservation of electrical. What is the question? Conservation of what?
of charge.
Conservation of charge. Energy, I think. But we will see as you continue.
Yes, that will be 2 months.
2 months.
Yes.
Will be 3 months.
So number 4, I think. Okay, read the question.
Calculate the charge of each year after they have separated.
So they both have charges. The other one is positive, the other one is negative. They are brought together and they are separated. Hence, now you divide by 2. You must understand why you divide by 2 because there are 2 charges. They are combined already separated. So it's as simple as that. And then mark the substitution formula. Substitution is 2 marks for Q1 and Q2 again. So, like you said, they can also ask for how many electrons were transferred. How are we going to do it? Again, you said electrons will move from Y to X.
Yes.
It's fine. So, if you were to calculate this, minus 4,8 minus 4, that answer.
Oh.
I don't know if you remember from the example here. I'm just saying, if you have a vote. What
Negative 4,8.
Charge in minus 4,8. No yana kebuka. So it means it was minus 4,8. Now it's 4.
Yes.
What happened to the charge? Did it increase or decrease? From minus 4,8 to 4. And then remember, it's the power 18, there is the power 19. Also from 18 to 19. Kadi negative. Are you increasing or decreasing? You are moving from minus 18 to minus 19. You are decreasing. Hence, like you said, they lost the charge. So I think DL is equal to.
Yes.
Yes.
What was the total? Can you put the total?
11 months.
Yeah, so the average of this topic, it takes about, I think, 13 to, I think, just less than 15. So out of 75 or out of 100, you must be sure this 10 marks or 15. You're sure.
Okay.
And then we can have the second one, it's fine.
Second one.
Thank you.